Hello mga kamatiks! So the topic that we are going to discuss this day is about the chain rule in quarter 3 module 7 lesson 1, 2 and 3. Okay, so we have here the learning competency, solve problems using the chain rule. Okay, so we have here the objective to use the chain rule to compute the derivative of f of g of x involving polynomial, radical, and rational function. To differentiate f of g of x, first differentiate the outside function f of x and substitute the g of x for x in the result. Then multiply the derivative inside the function of g of x. Symbolically, the derivative of f of g of x over dx is equal to the first derivative of g of x times the first derivative of g of x. Okay, another way to write the chain rule, given the function y is equal to f of g of x, set u is equal to g of x so that y is equal to f of u, then y may be regarded either as a function of u or indirectly through u as a function of x. With this notation, we have du over dx is equal to the first derivative of g of x, and dy over du is equal to the first derivative of u, which is equal to the first derivative of the g of x. Thus, the chain rule says that dy over dx is equal to dy over du multiplied by du over dx. Okay, so we have here the example of a polynomial function. Find dy over dx if y is equal to u to the power of 5 minus 2u to the power of 3 plus 8 and u is equal to x squared plus 1. Okay, so we have here the solution. Since dy over du, or the derivative of y with respect to u, is equal to 5u to the power of 4 minus 6u to the power of 2. So meaning to say that you are going to find the first derivative of y in terms of u. And du over dx, so meaning we are going to find the derivative of u in terms of x, since the value of u is equal to x squared plus 1, so du over dx is equal to 2x. So we have derivative of y over dx is equal to the derivative of y over du, or derivative of y with respect to u, multiplied by derivative of u with respect to x. Okay, so the value of dy over du is equal to 5u to the power of 4 minus 6u to the power of 2. And the value of du over dx is 2x. Then after that, we have to substitute the value of u, which is x squared plus 1, in the equation of 5u to the power of 4 minus 6u to the power of 2. Okay, so we have here 5, substitute the value of u, which is x squared plus 1, so it becomes 5 times x squared plus 1 raised to the power of 4, since the exponent of u is 4, minus 6 times the value of u, which is x squared plus 1. So substitute, it becomes negative 6 times x squared plus 1 raised to the power of 2 multiplied by 2x. So that is the answer of dy over dx, or derivative of y in terms of x, if y is equal to u to the power of 5 minus 2u to the power of 3 plus 8, and the value of u is equal to x squared plus 1. Another example, find dy over dx if y is equal to 4u cubed and u is equal to x squared plus 5x. Okay, so we have here the solution. First thing to do is you are going to find the derivative of y in terms of u and derivative of u in terms of x. So dy over du is equal to 12u squared. How to find 12u squared? From the given y is equal to 4u cubed, you are going to multiply the exponent to the base. Since the exponent is 3 and the base is 4, so we have to multiply 3 by 4. The result is 12 times u. Then subtract the exponent by 1. The result is 2 because 3 minus 1, the result is 2. So therefore, dy over du is equal to 12u squared. And du over dx is 2x plus 5 or derivative of u over dx. Since the value of u is x squared plus 5x, so meaning the derivative of x squared plus 5x is 2x plus 5. Okay, by using the chain rule, we have here derivative of y in terms of x is equal to derivative of y in terms of u multiplied by derivative of u in terms of x. Since the value of dy over du is equal to 12u squared, so you have to substitute to the given formula. Then the value of du over dx is 2x plus 5. So we have here, when we are going to substitute, the result is 12u squared multiplied by 2x plus 5. Okay, then we are going to substitute the value of u. So you have to copy all except of u because you are going to substitute the value of u based on the given. The value of u is x squared plus 5x. Okay, so dy over dx is equal to 12 times the value of u, which is x squared plus 5x quantity squared, multiplied by 2x plus 5. So therefore, the answer now of dy over dx is 12 times the quantity of x squared plus 5x plus quantity squared times 2x plus 5. Okay, so we have here an example for radical function. Given that y is equal to the square root of u and u is equal to the square root of x. Okay, so we have here, first thing is you are going to change radical to exponential form. Since the given is y is equal to the square root of u and the index is 2, when we are going to change that one into exponential form, it becomes y is equal to u to the power of 1/2. And the value of u is equal to the square root of x. So when we are going to change that one to exponential form, it becomes u is equal to x to the power of 1/2. Okay, so we are going to solve dy over du or derivative of y in terms of u. Since the exponent is 1/2, multiply to the base, which is 1. So 1/2 times 1, the result is 1/2. Multiplied by u raised to the power of 1/2 minus 1. So 1/2 minus 1, the result is negative 1/2. When we are going to simplify, the result is 1 all over 2u to the power of 1/2. Since the exponent of u is negative, so it becomes the denominator of the fraction. So the exponent of u now is positive 1/2. Then solving for the derivative of u in terms of x, since the value of u is equal to x to the power of 1/2, so the exponent is 1/2, the base is 1. When you are going to multiply, the result is 1/2 times x raised to the power of 1/2 minus 1. So the result is negative 1/2. When we are going to simplify, du over dx is equal to 1 all over 2 x raised to the power of positive 1/2, since x now is in the denominator. Okay, using the chain rule, dy over dx is equal to dy over du multiplied by du over dx. Okay, the value of dy over du is 1 over 2u to the power of 1/2 multiplied by the value of du over dx, which is 1 all over 2x to the power of 1/2. Okay, so we have here, we are going to substitute now the value of u. Since the given is u is equal to the square root of x, which when we are going to change to exponential form, it becomes x to the power of 1/2. So we have here 1 all over 2 times x to the power of 1/2 close quantity raised to the power of 1/2 multiplied by 1 over 2x to the power of 1/2. Okay, simplify. Since x is raised to the power of 1/2, then quantity squared 1/2. So uh, exponent to exponent, we are going to multiply. So 1/2 times 1/2, that is 1/4. The base, there is a base of 2 and another is 2. So 2 times 2, that is 4. Then the exponent here, first exponent of x is 1/4 because 1/2 times 1/2 is 1/4. Then another exponent of x is 1/2. When we are going to multiply, because that is 4x to the power of 1/4 times x to the power of 1/2, when we are going to multiply the same base, copy the base, then add the exponent. So 1/4 plus 1/2, the result is 3 over 4. So the answer now of dy over dx is 1 all over 4x to the power of 3 over 4, or when we are going to change that 1 into radical sign, it becomes 1 all over 4 times the 4th root of x cubed. Okay, another example of rational function. We have here y is equal to the square root of u plus 2 and u is equal to 4x minus 2. Okay, since y is equal to u plus 2 to the power of 1/2, when we are going to change the value of y, which is the square root of u plus 2, and we are going to change that one into exponential form, it becomes the quantity of u plus 2 raised to the power of 1/2. Then solving for the derivative of u over dx, since the exponent of x is 1, so multiply to the base, which is 4. So 1 times 4, the result is 4. Then copy the variable x, subtract the exponent by 1. 1 minus 1, the result is 0. X to the power of 0, the result is 1. Remember that any number raised to the power of 0, the result is 1. So 4 times 1, the result is 4. Then minus 2, the derivative of negative 2, which is a constant, is 0. So meaning the derivative of u over dx is equal to 4. Then we are going to find the value of the derivative of y in terms of u. Okay, so we have here the exponent of u, the quantity of u plus 2 is 1/2. So 1/2 times 1, the result is 1/2. Then copy the base, which is u plus 2. Then subtract the exponent, 1 minus, 1/2 minus 1, the result is negative 1/2. So the exponent of the quantity of u plus 2 is negative 1/2. Okay, so solving for dy over du, simplify, since the exponent of the quantity of u plus 2 is negative 1/2, it becomes a denominator. So dy over du is equal to 1 over 2 times the quantity of u plus 2 raised to the power of 1/2. Okay, then using the chain rule, we have dy over dx is equal to dy over du multiplied by du over dx. Okay, substitute. The value of dy over du is 1 all over 2 times u, the quantity of u plus 2 raised to the power of 1 half multiplied by the derivative of u over dx, which is 4. So meaning the value of 4 is multiplied to the numerator. So it becomes 4 all over 2 times the quantity of u plus 2 to the power of 1 half. Okay? Then, we have to substitute the value of u, and the value of u is 4x minus 2. Instead of writing u, you have to write 4x minus 2. Then simplify. We have, okay, so we can cancel the numerator, or we can divide the numerator, which is 4 divided by 2. The result is 2. Then 4x minus 2 plus 2, it becomes 4x raised to the power of 1 half. Since the exponent is a fraction, so when we are going to change that one into radical sign, it becomes the square root of 4x. So therefore, since we can find the value of the square root of 4, that is 2, and x is will remain in the radical sign. Okay, so it becomes 2 over 2 the square root of x. And if the numerator, no, the numerator is 2 and the denominator is also 2, so we can divide that one. The result is 1. So the final answer now for dy over dx is equal to 1 over the square root of x. Okay, so we have here an example of rational function. Given, find dy over dx, so the derivative of y in terms of x, if y is equal to u over 1 plus u squared, and u is equal to 5x plus 1. Okay, since this is a fraction, using the differentiation rule, we are going to identify the value of u and the value of v. Remember that the value of u is the numerator and the value of v is the denominator. And the value of u here is still u, and the value of v is 1 plus u squared. Using the quotient rule, we have here the v multiplied by derivative of u minus u derivative of v all over v squared. Okay, so we have here the value. The value of dy over du is equal to here, which is v, 1 plus u squared, and multiplied by derivative of u, which is 1, minus u, multiplied by derivative of v. The derivative of 1 plus u squared is 2u, all over the quantity of 1 plus u squared plus quantity squared. And we are going to find the derivative of du over dx, since the value of u is 5x plus 1, and derivative of 5x plus 1 is 5. Okay, then after that, we are going to simplify. 1 plus u squared multiplied by 1, the result is 1 plus u squared. Minus u times 2u, the result is negative 2u squared, all over the quantity of 1 plus u squared plus quantity squared. We then simplify or combine all similar terms. 1 plus u squared minus 2u squared, the result is 1 minus u squared, all over 1 plus u squared plus quantity squared. Then after that, we are going to use the chain rule. And the formula for the chain rule is dy over dx, or the derivative of y in terms of x, is equal to dy over du, or derivative of y in terms of u, multiplied by du over dx, or derivative of u in terms of x. Okay, substitute dy over du, and the value of dy over du is 1 minus u squared all over 1 plus u squared close quantity squared. And the value of du over dx is 5. Then after that, we have to substitute the value of u. And the value of u based on the given is 5x plus 1. Okay, so instead of writing u, you have to write 5x plus 1. And we have here for the denominator 1 plus u squared. So we have to substitute 1 plus the quantity of 5x plus 1 squared plus quantity squared multiplied by 5. Okay, so we have here the result. 1 minus 5x plus 1 quantity squared. The result is 1 minus 25x squared plus 10x plus 1. So ang 1 we have to cancel because 1 minus 1, the result is 0. So the remaining value of the numerator is 25x squared minus 10x multiplied by 5. The result is negative 125x squared minus 50x all over the denominator, which is 1 plus the quantity of 5x plus 1 squared plus quantity squared. So this is now the value of dy over dx. Okay, so what's more? We have here find dy over dx using the chain rule. Okay, so we have here the example. There are 5 examples there are 2 examples of the polynomial, or 3, sorry. There are 3 examples of the polynomial and 1 example for the rational and 1 for the radical. Okay. Thank you for listening. Do not forget to click the subscribe icon.